So for this project, the materials that we're going to be using are very simple. Yet again, we will be using our multi-purpose shield, Arduino shield. We will require an Arduino. And the novelty is that we are going to use a sensor, an ultrasonic sensor, such as this one I'm holding. You will find a description in the project's list of materials and where to buy it. These are very cheap ultrasonic sensors. And a display. Now for the display, we can use just a simple display that you can come with. It comes in any Arduino kit that you might buy. Also in the bill of materials in the description of the project you can find this display. Or you can, however, use a protoboard such as this that comes up with an integrated display. You will see the display is fairly similar. But the advantage of this is that these displays come already wired in, so you don't need to complete a full wiring of the display in order to use it with the Arduino. So we will be using this board, which not only comes with this display but also comes with a bunch of buttons and also form factor, so you can plug a number of different Arduinos, not only the Arduino Uno itself. In the Biomaker website you will find a more thorough description of this board and some modification that you need to do to it, basically soldering or desoldering some ports in order to use the display. I'll cover that later in the tutorial, and it's also, as I said before, already documented in the Biomaker website. So there we go again. Let's just plug the Arduino into the board. It's just very easy. You just need to plug this into the pre-soldered form factor here. It's very easy. Let's just try to make it Arduino properly plugged here. And now the shield, a bit of the same. You find it very easy. In order to connect the sensor, you will notice that there are 4 pins. One is for ground and the other is for power, so these two at the extremes we use to power the device, and the other 2 are just the trigger and the echo, so the set and receive of the ultrasonic pulse. That should be pretty straightforward, so let's just plug these 4 guys here. 2, 3. Here we go. Here we are. Remember, as I mentioned, there's a tiny little modification you need to make to the board in order for it to work properly. But for now, let's just wire the circuit, and that would be first of all what you need. The first thing that you need to note is that the voltage and the ground are related to powering the sensor. So let's take the voltage, which is this orange cable here. Sorry, that's the ground, and the voltage, they should be all the way around, but whatever. Let's just plug them into these corresponding pins, ground and voltage. So the ground would go here into ground, and the voltage go to the voltage. So put 5 volts. There you go. That's all you need. And then let's connect these 2 guys into digital pins into the Arduino. Let's say digital 6 and digital 5. For instance. And that's the circuit. Now the next thing that you need to do is just to start XOD, power the circuit, program the circuit, upload it to the Arduino, and you will be done. Okay, so let's real quick have a look at how to program the Arduino using these components. So the first component we're going to use would be Marcos buzzer. Here it is. Let's grab it here. The second component would be the ultrasonic wrench. Just it is here. And the third component would be our display. We are using I2C protocol to communicate, so we choose the I2C to line the Excel CD. Now, we need to choose between the Theremin or the distance alarm. I would start with the Theremin, which is like the simplest circuit. The logic is not that complicated. We only need to read the distance that comes from the sensor, print it into the screen, and change the frequency of the buzzer according to this reading. So let's just do this very quickly. As we discussed before, trigger and echo are the ports in which our sensor is being plugged. So let's say we said that they were digital 5 and digital 6, so I'm gonna put echo in digital 6, and trigger in digital 5. So digital 6 and digital 5. Cool. Now there are 3 nodes here. This is the distance measured. So what we need to do is to send this distance, because we want to print a string into the screen. Sorry, we don't do that. I'm just gonna get rid of that. Sorry. We need to find a concatenation. So we need to concatenate strings. It's probably gonna be in bits, perhaps. Nope. Maybe in the core I input and output. I don't know. Here it is, concat. So this function does exactly that. Takes a float value and concatenate it into a string. So that's very easy. Let's say the distance measure is going to concatenate, and then we need to put the strings we want to be printed in the 2 lines. Let's say distance in line 1 equal to, then the value, and then meters. So we're going to use meters. That would be all in the first line. This then connects to the screen, which, as you can see here, contains line 1 and line 2. And then the other thing that we need to specify is the address. We're going to use the bus 20H. So here we have, we measure the reading from the sensor, concatenate it into a string, which we feed into the screen. That bit of the program is then properly completed. Now,
In the case of the buzzer, what we want to do is take the value of the reading and change the frequency of the buzzer. So what we're gonna do is very simple. We're gonna multiply the value that we read, so we can put it in a range that it's more or less not that offensive to our ears. So let's multiply it. Then we can multiply it by, let's say, 1000. So that will turn it into hertz, I suppose. So you've measured your meters, like, I don't know, 0.50 whatever meters, like some millimeters, centimeters. You need that to be in value of hertz. And then we connect this to the frequency of the buzzer. Of course, we need to check that our buzzer is connected to the port D5 in our shield. So here we are, we only need to enable it to be true. And here we are, we have our full circuit wired. So now we only need to just upload it to the Arduino. So let's upload to Arduino. Let's check that it is there. Hopefully I'll have the permissions. We'll see. We're uploading it. It's deploying. Yes, we need to add some permissions. Let's see. Let's just here we are. Now let's just deploy it. As we see there, it's uploading. And it's gonna be deployed. Perfect. Now we can just turn the Arduino on and off, and it will work very well. Excellent. We'll test the circuit in a minute. Let's do something else. Before we do that, let's just review the code to set an alarm in case of proximity. The circuit is very easy, but the only difference would be that in this case, instead of changing the frequency of the tone of the buzzer, what we need to do is to change the frequency of a signal that we send to the buzzer to ring. So what we're gonna do is we're gonna take a square wave or a signal, square wave, and then we are gonna multiply this by the period. We can just need to put a period, let's say 0.3, 0.5, let's say put 0.3. Enable true. Perfect. And that now that the output is computed, we send it into the buzzer. This would give you the distance code that we want. Again, you upload this to the Arduino. Let's upload it to the Arduino. Well, of course, the Arduino already got the Theremin code, so I'm gonna wait a minute, and I'm just gonna show you the Theremin. I'll show you the distance, and that concludes the tutorial. Thank you very much.